Okay, first of all, please subscribe my channel and watch online, and do not try to download my videos. In this lecture, I want to speak a little about a special kind of interpolation, namely spline. Splines, okay? In the previous lecture, we saw some different kind of interpolation. For example, we had Lagrange interpolation, Lagrange interpolation, and if I want to show you the Lagrange interpolation in a figure, I can show something like this. Suppose that we have something like this. Let me change the thickness of the line here. Something like this as axis, and we have in fact a plot of a function like this one. Okay, we have something like this, and we interpolate this function, call it y equal to f of x. And now let I find an interpolating polynomial like p of x, and when we draw this one, we have something like this: p of x equal to y. Okay, if y equal to f of x is a function and y equal to p of x be the interpolating polynomial of f, then you can find that in some points this in fact interpolating polynomial and the function have the same values, and in the other parts they have different kind of values. But we have one more thing. In fact, this is a continuous interpolating polynomial, and p of x is in fact is a polynomial of degree n. For example, 5, 4, 6, and so on. But there is one more kind of interpolating polynomial. We call it piecewise interpolation. Let me fix it. Interpolation. What's a piecewise interpolation? We have, for example, a function like f of x, like this. Where am I? We have a function like this, for example. Okay? If you, in fact, specify some point on the x-axis, like x0, x1, x2, x3, x4, and so on, xn minus 1, and finally xn. And if you find a point here f of x0 and a point here f of x1, a point here f of x2, point here f of x3, f of x4, and so on, continue until here and here. And if you connect all of these points, okay, all of these points by some straight line like this, okay, something like this, exactly something like this, and we continue in the same way, and finally we connect these 2 points and so on. Okay, if we call this function y equal to f of x, we call this piecewise lines, in fact we call this piece of lines as the piecewise interpolation polynomial for f. In fact, we interpolate the function y equal to f of x by some linear function. Each of these parts, if each of these lines has an equation like ax plus b, y equal to ax plus b, and if we connect all of this line, we can find a polynomial, okay, that each parts has a degree 1. Okay, this is the piecewise interpolation. About the piecewise interpolation, we have several different kind of interpolation. For example, if we use linear functions between each 2 points, we have piecewise linear interpolation. And if we have a function of degree 2, okay, so we have in fact a spline of degree 2, and it is very natural that we use in fact polynomial of degree 3 between each 2 points. In this case, we call in fact the polynomial, the interpolating polynomial, we call it spline, we call it cubic spline, in fact. Okay, so let me write some explanation here. If we use a function of, in fact, instead of function, let me write a polynomial. A polynomial of degree 1, we have piecewise linear interpolation. Okay? If we use a cubic polynomial between each 2 nodal points, we call it cubic spline. Okay, so the cubic spline in fact can be defined like this. But what is exactly the cubic spline? We want to start to, in fact, study the cubic spline. What is cubic spline? What's the necessary definition? And how can we find a cubic spline for interpolating a function? First of all, let me define a mathematical, in fact, explanation for the cubic spline. So let me write a definition here. Let delta b equal to x0, or in fact a equal to x0 less than x1 less than x2 less than xn equal to b be a partition of a and b. Okay? The function s from a and b to r is a cubic spline, is a cubic spline if it has the following properties. The first property is S belong to C squared over A and B. What does it mean? It means that S has continuous derivative up to order 2. So it means that it has the zeroth derivative, or in fact S is continuous on A and B, S prime is continuous on A and B, and S double prime is continuous on A and B. The second part, the second property, in fact, it is that S over each subinterval xi and xi plus 1 be a third degree polynomial in P3, in fact. Okay, so if I want to define in fact the cubic spline, I can say a cubic spline is some third degree polynomials which each two polynomials close to pi minus 1 and pi are continuous at xi and this is true for first and second derivative of these polynomials. Okay? If I want to show this explanation by a picture, I can show you something like this. Let this is xi minus 1, xi, and xi plus 1. We define pi minus 1 over x minus 1 and xi. And we define pi over xi and xi plus 1. Okay? The second property of the cubic spline says that pi minus 1 at xi should be equal to pi at xi. Consider xi. So pi minus 1 at xi should be equal to pi at xi. Also, p prime ai minus 1 at xi from the left, consider here pi minus 1 can be defined over xi from left. Okay, it should be equal to pi prime at xi from right. Okay, and for the other one, p double prime I minus 1 over xi from left should be equal to pi double prime over xi from right. So, in fact, the second property of the spline can be explained by these three equalities. Okay? So, now what can we find? Now, in fact, we want to find some interpolating polynomial, cubic polynomial, like this p1, p2, p3, p4, and so on, such that in fact the collection of all of these polynomial can interpolate the function f. Okay, the function f. So now let y0 to yn be n plus 1 numbers. Okay? When we say spline interpolating, we mean that find a function s from a and b to r such that s at xi be yi for I equal to 1 to n. Okay, s at xi for I equal to 1 to n be equal to y. Here I should mention that x0, x1, 2, xn are nodal points, in fact. So we want to find something like this. But what is the main idea behind the spline interpolation? Let me stop this lecture here and continue the lecture, the idea of the spline interpolating in the next lecture. And let me at the end of this lecture ask you again that watch my videos online and do not try to download, and also please subscribe my channel. Thank you.